afternoon, class. How are you all? We have mathematics. And we are going to continue with our topic, vectors, that we started last week. Today, we will be learning a new subtopic, which is magnitude-bearing vector. So, what we'll be doing under this subtopic is, we are going to learn how to change a vector from the component form to magnitude-bearing form. So a vector in the component form is given as vector AB is equal to x, y, where x represents the vector in the x component, and then y represents the vector in the y component. To write or change a component vector, this form, to magnitude-bearing form, the vector will be written in the form as vector AB is equal to A units, comma, B degrees, where A units represents the magnitude of the vector AB, the distance of the vector AB, or the length of the vector AB, and B degrees represents the direction of the vector AB from the North Pole. Now, to change a component form of a vector to the magnitude form, we first have to find the magnitude of the vector. So if we have the vector xy, AB as x, y, we are going to find the magnitude of the vector AB. So the magnitude is calculated as magnitude of vector AB is equal to square root of the x squared, that is the value of the vector along the x component square, plus the value of the vector along the y component square. When we are done with the magnitude, the next thing is we have to sketch the vector in the x and y plane. So positive y, positive x, negative y, negative x. So the sketching of vector x, y, which is for vector AB, the point A, then to here B. So vector, so this is x, y. Then we have to find the angle the vector AB is making with the x-axis. So we can find that by drawing a right angle triangle from the vector. Then we calculate the angle it is making with the x-axis. So the angle is being calculated by taking a trigonometry ratio, specifically tan. So tan of the angle will be equal to opposite of the angle divided by the adjacent. The opposite side of the angle is equal to the unit along the y-axis, while the adjacent side is equal to the unit along the x-axis. So tan theta is equal to y over x, where theta will be equal to tan inverse of y over x. So for example, if we are given the vector AB to be equal to 3, 4 in the component form, and they said we should change it to magnitude-bearing form, we are going to find the magnitude first. So magnitude of vector AB is equal to square root of 3 square plus 4 square. This will give us 9 plus 16. Then we'll get square root of 25, which will give us 5 units. So now we are done with calculating the units, the magnitude for the vector. The next thing is to find the direction. So our y, then our x. The vector AB has 3 units along the x-axis. Then it has 4 units along the y-axis. So vector AB. The magnitude, the length of vector AB is what we calculate for and got the 5 units. So we are going to form a right angle triangle, calculate the angle it makes with the x-axis. So this will be equal to tan theta is equal to the opposite of the triangle, which is equal to the unit along the y-axis, 4 over the unit along the x-axis, 3. Then theta will be equal to tan inverse of 4 over 3. Theta is equal to 53 degrees to the nearest degree. So when we are done, because bearing is calculated from the North Pole, we have to find this. That is the direction of vector AB. So we will have to subtract the angle we calculated for from the total angle of this quadrant, which is 90. So the direction of vector AB is equal to 90 degrees minus theta, which is 90 degrees minus 53 degrees, and that will give us 37 degrees. So now that we are done with calculating the magnitude and then the angle, we are going to write it in a form of the magnitude bearing form. So vector AB will now be equal to the magnitude 5 units, comma, and then the direction 37 degrees. So what we have learned is how to change from the component form to magnitude bearing form. We said first we have to find the magnitude of the vector, then sketch the vector in the Cartesian plane, calculate the angle it makes with the x-axis, then we subtract it from or add it depending on the quadrants. So next week we will be learning about how to change from the magnitude bearing form to component form of a vector. So read on it so that when we meet we will be able to go fast. Thank you.